In math, sometimes we look at the path of a projectile that has been fired from a fixed position. That position can be either at ground level or on a high perch, kind of like a building or a cliff. In our example, a projectile is fired from a cliff that's 200 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. The height h of the projectile above the water is modeled by h of x equals negative 32x squared divided by 50 squared plus x plus 200. So all the information they gave you at the beginning, they did the work for you and just told you this is the function that comes from it. So also, x is the horizontal distance of the projectile from the face of the cliff. So knowing all this, our first question is, at what horizontal distance from the face of the cliff is the height of the projectile a maximum? So since we know we have a quadratic equation and it's asking for the maximum, we're just going to find the vertex. So our a value here is going to be negative 32 over 50 squared, and b is going to be 1. Now we just plug it into our vertex formula. So x equals negative b, so negative 1, divided by 2 times a, so negative 32 over 50 squared. And you can just shove this all into a calculator just to get your answer. But you're going to get approximately, and I'm going to round to 1 decimal place, 39.1 feet. So at what horizontal distance from the face of the cliff is the height of the projectile a maximum? 39.1 feet away from the cliff. So if we know how far away from the cliff the max height is, what is the maximum height? So we're just going to take our 39.1 and we're going to plug it into our equation. So I'll show it again right here. So we're going to have h of 39.1 equal to negative 32 times 39.1 squared over 50 squared plus 39.1 plus 200. And just like with the other one, just be careful with simplifying because there's a lot of stuff going on here. But when you plug it all in and work it out, you should get 219.5 feet. So what is the maximum height of the projectile? 219.5 feet high and 39.1 feet away from the cliff face. So now, at what horizontal distance from the face of the cliff will the projectile strike the water? So when will it land in the water? So when it lands in the water, it is essentially no feet above the water. It's 0 feet. So we're going to take our height function, our h of x, which is negative 32x squared over 50 squared plus x plus 200. And all we're going to do is just set it equal to 0. Because our height is 0, so that means the entire equation needs to be set equal to 0. So a is going to equal negative 32 over 50 squared, b is going to be 1, and c is going to be 200. So I'm going to write it all out to how it should be put into the quadratic formula. I'll leave it to you to do the math on your own, but it should come out as negative 1 plus or minus the square root of 1 squared minus 4 times negative 32 over 50 squared times 200 all over 2 times negative 32 over 50 squared. And again, just do all the math here, but when you do this, you're going to end up getting 2 answers. You're going to get x equals a negative 91.9 feet and x equaling a 170 feet. Now, at what horizontal distance from the face of the cliff? Well, if we're having a negative 91.9 feet, that means instead of being launched from a cliff face like so, going that way, we would actually be going the opposite direction, kind of like if you were to finish it off. So shooting off a cliff goes this way, but a negative distance like this doesn't work. It doesn't work that way. So we don't like negative distances. We don't like negative time. So we can remove this as an answer. Whereas this, a positive 170 feet, that is good. So at what horizontal distance? 170 feet away from the face of the cliff is when it'll strike the water. So now, when will the height of the projectile, when the height of the projectile is 100 feet above the water, how far is it away from the cliff? So just like with before, when we set our equation equal to 0, because that's how many feet above the water it is, we know that it's 100 feet above the water. So we're going to take our equation and we're going to set it equal to 100. And now I'm going to subtract the 100 over. 32x squared over 50 squared plus x minus, or plus 100, excuse me, equals 0. And we still have a and b being the same, but c this time is 100. So again, putting into our quadratic formula, x equals -1 plus or minus the square root of 1 squared minus 4 times -32 over 50 squared times 100, all divided by 2 times -32 over 50 squared. Now again, when you plug this all into a calculator, you are going to get two answers. Those two answers are x equals -57.50, not 8, 58 feet, and x equals 135.7 feet. Now, just like before, we can't have negative distances, so the -57 feet we can just get rid of, and we just keep the positive distance here of 135.7 feet.